Welcome back to Data-Driven Engineering. We're going to go through the final module in this Introduction to Python. This is our overview with Pandas being the very last one. And so if we come down here to Pandas, you'll see the material. Again, you can go to GitHub and get the file. Okay, save link as under the raw, and then go ahead and save that. And there's also a Google Colab link right here. And if you select this, it'll bring it up in a web browser. You don't need to install Python. All right, so that's how we access the content. Also, as you go down through, we're going to have some knowledge checks that are located throughout. And so if you just select this, you can see the solution. Okay, so it's just a button that hides the solution. If you select it, it will show it to you. All right, so that's, let's go ahead and just open up the Jupyter Notebook. And we're going to go through a list of these topics right here. Okay, we're also going to talk about Pandas install and import, Pandas Series, DataFrames Analytics, Visualization, and Export. And right here on the right, I will try to mark this as we go through each one. So we're going to start with install as the very first part of it. Now this Pandas package comes with Anaconda and some other ones. It comes standard, but if you don't have it, go ahead and just do pip install pandas. All right, and that's going to install pandas. You can do that through this cell right here, or you can come to the Anaconda prompt. All right, pip install pandas. Okay, it says it's already satisfied. You can see the version here, 1.1.3. And we're going to check to just see if it has the latest version. So if you go to pypy.org, and here is Pandas, you can see that we're at 1.5.2. Okay, so we don't necessarily have the latest version, and I'll show you how to upgrade that if you'd like to. All right, let's also go to pip install pandas profiling. That's another one that we have, and if you just put it to, I'm going to export any of the details to this text file because it has a lot of things that are output. If you want to see the results, just open up that file in your same run directory. All right, and that should be located right here. Okay, so here's the Pandas profiling, and it shows just a list of the packages that it requires. Okay, so all of those are satisfied. That's why I put it out to a text file. Okay, so let's go ahead and check the Pandas version and other information. Pip show pandas. And that'll show that it's 1.1.3. All right, if we have some features of different things that we need later, we can always upgrade to 1.5. Okay, and to do that, you just do pip install pandas -- upgrade. But I'm not going to do that right now, just because a lot of the Anaconda packages, like NumPy and other things that it depends on, they also have versions that they're dependent on. And so I know it's compatible right now, so I'm not going to upgrade, but you can do that if you do -- upgrade. All right, let's go ahead and import pandas. There's a couple different ways to do that. You can just import pandas, or you can shorten the name and do as PD. You could also just import specific methods that are in there. So we can do import pandas as PD, or from pandas import DataFrame. All right, so either one of those are going to work. Now, do not do this. It is possible to do that, but then you clutter the namespace with all of the different method names, and there might be conflicts with other packages, so you never want to do that. All right, so there are Pandas functions for reading data, statistical description, analyzing, organizing, and visualizing data. We're going to start with a series, okay? Creating a Pandas series and then move on to a data frame. A series is like just one column of a data frame. It has an index, but it's just meant for just one series of values. A data frame is more like a table where you have multiple columns, each with a different column header and description, but they're all bound by the same index. Okay, we're going to also talk about reading CSV, describing, plotting, and then putting out the results of the data frame to a CSV file. All right, so let's start with the Pandas series now. All right, so we had, first of all, we covered this import right here. We're done with that, and install. Now we're going on to series right here. Okay, so in the series, we're just going to create a new series with pd.series, and we're just going to give it a sequence of numbers. And let's go ahead and just print out y. All right, so there's our series of values. You can see the index value here that references the value here. So it's kind of like a dictionary with a key pair. The index, you can really think of that as like something that keeps track of which record or which row is there. All right, let's use the dot values just to return the values of that. And that's going to return it as an array. All right, and if we look at the type of that, so what is the type of that? It's going to be a NumPy array. So as we reviewed in the last section, NumPy is a base package for Pandas. So it's an underlying package that stores the series values. All right, and then you can export them with dot values. All right, so let's just show only the index of y as a list. So we can also do index. All right, and that's going to be between 0 and 5. But let's convert it to a list instead. So that references one of our earlier subjects about lists. Okay, so we can also name the index. And now we're on to this next one right here under index. All right, so if we want to name it, we can give it a name. Like let's do something like with planets here: Mercury, Venus, Earth, Moon, and Mars. Okay, and then go ahead and put them out. So this is going to be some data with regard to these planets. And this is the mass of the planets. Okay, in I think it's 10 to the 24th kilograms or something like that. Okay, so the relative mass of each of these. So instead of 0, 1, 2, 3, 4, now we have the names of the planets. Now let's go and retrieve a single value by name. So if I do y bracket Mercury, all right, this is going to be 0.33. So it's very similar to a dictionary in terms of a key value pair. But in this case, it's called an index. So the key is kind of like an index, it's the row. But as we get to data frames, we're going to have additional values, additional columns that are here. So even though the series index has changed, so we called it Mercury instead of 0, we can also access it by the original number index. All right, so let's go and calculate the ratio of the weight of the moon to the Earth. So to do that, we're just going to go the ratio of the moon divided by the weight of the Earth. All right, so the moon weighs about 1.2% of the Earth. All right, so let's go ahead and just look at a series slice. All right, so we're going to create a Boolean. I guess we already did the retrieval there with the index. Now we're going to go on to slices. Okay, slicing the okay, let me write that a little bit better here. There we go, slice. Okay, so we're going to take just a subset of this, and we can do this. We can create a Boolean true false list of values that meet a logical condition. So for example, with these operators right here. So any of those, we can reduce down the set. Okay, so let's look at all the ones that are less than 1. So we have Mercury is less than 1, the moon, and Mars. Okay, so that's less than that mass. Now we can also use to just retrieve and create a new list. Okay, so we're going to take the true, false, false, true, true, and just the ones that are true are going to be returned in that list. So I've reduced this down from here. I've eliminated these two that are greater than 1. And I now have a new series that just has the ones that are less than 1. All right, we can also retrieve a slice of values by referencing the names. And that's going to be maybe Mercury to Earth. Maybe I want to include all of those. All right, and leave off the other ones that are outside of that range. Now, if I print Y, originally I could see that I had Mercury, Venus, Earth, Moon, Mars. So I've left off these two by ending at Earth. All right, we can also use a step as well. This is a third parameter in there, so you can, let's go ahead and just go y 0 to 5, but go in increments of 2. So I'm going to take every other one. So again, if I print y, I could see that I have Mercury, and then I went to Earth, and then to Mars. So if I put this increment here of 2, then I can see I skip over Venus and Moon. All right, let's do a knowledge check now. Let's create a new series with only the planets less than 0.5 times 10 to the 24th kilograms or greater than 5 times 10 to the 24th kilograms. Okay, we're going to use the OR operator, which is this horizontal line. All right, or character. All right, so let's go ahead and create a new series. I'm going to just say, let's go y, all right, is less than 0.5 or y is greater than 5. And it looks like I have a type error here. Let's see what that is. I think I need to put parentheses around here. There it is. So I just had to put parentheses around here. So to evaluate this first and then do the OR comparison between them. So it has, this true for Earth because that was above 5. But then this one is less than 0.5 and that one is less than 0.5. So if I want to create a new one, a new series that just has those, then I would say Mercury, Earth, and Moon. And I can see the values of those. All right, so this is a new series with only the planets that are less than 0.5 or greater than 5. And we're using this OR operator here. All right, now if you wanted to try to use the OR like that, it doesn't work because you have to do a bitwise comparison. So you got to use this one instead. Find the length of a series with leny. Okay, so this is going to be equal to 5 because we have 5 in there right now. We're going to import some more, but we can export now. Let's see, we just did length right over there. Now we're going to be getting to sort and data frames, but let's go ahead and just do convert to a dictionary first of all. All right, so there is to the dictionary, and you can see that the series is now a dictionary format. So in case you want to just use a dictionary instead, it's easy to convert the format over. Okay, we're going to also say, see the to CSV. There's other ways to export this data as well. All right, let's go on to sorting now. Okay, so this is our next topic, how to sort the values by index. Okay, we can do sort index. And it's going to put it in a form in alphabetical order. Okay, Earth, Mars, Mercury, Moon, Venus. Okay, we can also use ascending equals false. Or, so this is the largest value first, all the way down to the smallest. If I go true, Then I'm going to reverse the order. Okay, so we can sort values instead of sorting by index. Now we can also go back to what we had before, the rank, and we're just going to go ascending equals false. So this is the original order that we had before, like the 0, 1, 2, 3, 4. All right, so let's create a new series with the 3 smallest solar system bodies in the list Y. So I need to sort by values. So we're going to take this one and just do the first 3 values. Okay, so I'm going to sort the values, but then I just want to take just the first 3 smallest. Okay, so I'm going to put something at the very end, and it's going to take a subset. So I could either do this, z equals that. All right, and then I could do z 0 to 3. Okay, that'd be another way of doing it. And then I've just taken this slice of those, and I could even say w equals that, and then print out w. Okay, so w is going to be that slice of those. All right, let's go on to data frames now. So this is an important topic beyond just the series. A data frame is going to have multiple columns, similar to like a spreadsheet in a spreadsheet document with a table that has identifiers for the rows and column names. And these are very powerful to be able to work with data. All right, so we're going to create a data frame from 2 lists, X and Y. So I've got X and Y. And let's go to create this new data frame. We're going to use the Pandas.DataFrame. And we'll start with just a dictionary. So X and Y. And then let's look at this data frame. All right, so just like a series, it has an index. But now instead of just a single value, I have an X column and a Y column here. Now let's go ahead and just import some data. So we're going to use the reads CSV. We're going to import it from a URL. And let's get some planet information. We had some planet masses there, but let's go ahead and import a table. So I'm going to import this table, and there is information on the planets. All right, if I come to this URL and just plug it in, I can see what I imported. Okay, so this was the CSV file. You can open up it with Excel as well, or you could open it up with a text editor, and you'll see that they're just comma separated values that are in this file. All right, and I'll open this up with a notepad. Okay, and I can see what it looks like here in the notepad editor. Okay, so there I've imported this as a data frame. So just this CSV file, imported it. And let's go ahead and just set the index, okay, the row label to this first one right here, which is just the property. So let's go ahead and use the set index. And I'll try this first of all, because if you run the cell again, it's going to say that that property doesn't exist, okay, because it's already an index. I'll say in place equals true. So I don't have to do PL equals PL.setIndex. I can just do PL set index. It'll replace the contents of PL with this new data frame that uses property as the index. And then it says property is already set as index. All right, so let's go ahead and run this. And you can see that now I just did the first 3 rows just to show it. But you can see that the property is now the index. Now we can also transpose. We can transpose this table, and we could say that PL equals PL transpose. And let's just go ahead and print that out. So now I have, instead of these as my columns, now these are the index or the rows, and then these properties are now going to be the columns. Okay, so let's change each of the column names with dot columns. So these names are pretty, there's a lot of characters there. We want to have something a little bit shorter, makes it a little easier to reference them, especially when you're dealing with the data and have to do the programming with it. Okay, so I'm going to just change the column names. I'll just sort that to mass, diameter, DIA, density, gravity, distance to the sun. Okay, so orbital period, orbital velocity, temperature, pressure, moons. Okay, so I've shortened it. It makes it a little bit easier to work with. All right, let's create a new column with within this data frame. And we'll just set that equal to 5. And let's look at our new column there. You can see I've created this right here with values of 5. Now I only need to put in one value and then put it in for all of the rows. Okay, we can rename a column with a dictionary of old and new names. So again, we're going to use the in place. We're going to use the pl.rename columns equals, and the new column, we're going to replace that with NC instead. So we're going to replace this longer column name with NC. And we'll do in place equals true, and then just look at the header of this. And you can see I've shortened the column name. Now we can also delete a column. So this one, we're going to use DL, PL, and C. So we're going to now delete this column. And if it can't find it, it's going to return an error. So I'm just going to use this try except. So if you run it again and it's not there, then it won't return an error. So if you run it again, it just says NC was not found. All right, let's do a knowledge check now. We want to compare the density of, okay, density's right here, but we have the other information here. We know how to calculate density from the diameter and from the mass. So we're going to use that information just to calculate the density and see if the mass and the diameter are consistent with this density. Okay, because density is mass divided by volume, and we know how to relate the diameter to the volume with this equation right here. All right, so here's the formula that we're going to use right here. So let's go ahead and just set this up with PL, and this is going to be density calculated, and that's going to be equal to 6 e to the 15th, and then I have to divide it by pi, but I need the value of pi. I don't have that there yet. You could do something like, pi equals 3.1415 like that, or we can just from numpy import pi. Okay, so it's already there in numpy. Let's just use that one. It's going to be a little bit more exact. And then I'll multiply it by PL, and this one is going to be mass. And then PL, and this is diameter, and I'm going to cube that value. All right, and then let's look at the output of this. Oh, I shrunk that a little bit too much. Okay, so there's my calculated density right there versus my reported density. And you can see they're pretty close, but some of these, like Saturn or Uranus or Neptune, Jupiter, they're a bit off. Okay, so this one's off quite a bit right there. So part of this is that these gas giants, they don't really have a defined diameter, so there might be some discrepancy between the diameter number and what they use to calculate the density and how that's defined. Also, on Earth, the diameter of the Earth is not constant. That might be an average value. And so the density, maybe this is a more accurate density value. How do you assume what the diameter is in different parts of the Earth? So there might be some difference between the density values that are reported and the density that's calculated. All right, let's go on to just inspecting Okay, we've covered transposing already. As we now let's go on to inspecting, where we're going to use head, tail, and sample to inspect some of the values. So I'll look at the head. If I do that, I get the first 5 rows. And you can also do put a number in there just to limit it to a certain number that you want. So if you wanted to put in even something like 7 or 2, okay, so you can reduce or expand that. Let's do a knowledge check here. Display 3 random rows from the planet PL. So I haven't shown this to you yet, but I did put it right here, .sample. So if we go pl.sample with 3 random rows, and if I run that again, you can see it changes the random values. So it allows you, with large data sets, just get a view of what's at the beginning, what's at the end, and then what are some sample values in between. Okay, let's go on to another topic that is the cleansing of data. All right, so it's important to ensure that you don't have missing numbers or those are handled correctly. Also, we don't want outliers. Okay, outliers are a big problem, especially in the machine learning or other areas where, you know, just a couple outliers can have a very big effect on the outcome. And also the duplicate data. We're going to remove the duplicate data and any incorrect data is identified. All right, so we're going to, first of all, let's say we want to drop the planet Pluto. All right, it's not in here, but let's say it were added, then we'd want to drop that planet if somebody made a decision that that was no longer a planet. Okay, so there it is. So row Pluto wasn't found, but you could run this just to cleanse the list of planets so that that one is not included. All right, we can also, in addition to DEL, you can use the drop axis equals 1 to search over the column names. So for example, if we wanted to drop diameter, I would look over axis 1. Those are the columns. And we'll say in place equals true. And then take a look at this again. And you can see now that diameter is no longer here between these two. All right, another decision is how to handle missing values. So we have a couple missing values here that are these NaN. This is the pressure right here. This would normally be the pressure at the surface. So here's like 1 atmosphere, 0.01 atmospheres, 92 atmospheres, 0 atmospheres. But these are gas giants, and there's really not a defined surface, so it's hard to define the pressure. So we need to do something with those because that can cause some problems with our calculations if we're doing averages or things like that. So we can do one of a couple different things. We can drop, okay, those rows that have not a number in them. So drop NA. It's a very common one, especially if you have a lot of data and you don't mind if you just want to just delete those rows that have not a number in them. All right, so instead of removing the rows with drop not a number, let's replace those with 0. So to do that, you do fill NA, and we'll just replace them with zeros, and then let's just look at the result. Okay, let's do in place equals true. All right, so you see these values right here are now equal to 0 instead of NaN. All right, let's look at some analytics or statistics of our data frames, okay, of our data. So we have count, mean, standard deviation, min, 25th percentile, 50th, 75th, and max. So the way that we could do that is just with this describe function. It creates a very nice summary, and okay, with the count, mean, standard deviation, min, the quartile information. So it's a good way to just get a nice overview of your data set, and especially if you have tens of thousands, hundreds of thousands, millions, billions of data points. There are some additional statistics that we can use as well. All right, so you can use mean, median, and some of these other ones. I'm just going to do the mean value. Shows the mean of each of the columns. Now, the default axis 0 computes the summary statistics over each column. To calculate for a row, use axis 1. All right, so there I have for Mercury, Venus. I don't know why this statistics would be useful, but there's an average of all the values for each of the planets. Now, another package that you can use is Pandas profiling. So this is common for exploring data, where it creates a very nice summary report for you. We're going to go with profile report, and then explorative is true and minimal is false. Earlier versions of Pandas profiling do not have these. So I'm going to do to notebook iframe. And as it creates this, we're going to get an error here. I think because it doesn't like, okay, so it's incompatible versions. You saw that earlier. I'm going to try to go back up and fix that right here by upgrading. This might backfire on me, but let's just go ahead and try it. Upgrade. All right, I'm going to try to upgrade here. So it looked like an incompatibility between the NumPy version and the Pandas profiling and the Pandas. This was a little bit earlier version, and then we just need to restart our kernel to use the updated package. All right, let's go ahead and just install this one as well. See if we can upgrade it. All right, so I'm going to do restart and run all, just so it'll go through all of my cells and run them again, and then we'll get back down to this point, see if we can do some Pandas profiling. If not, then looks like we still have an error here. Okay, it looks like cannot import named data error. So looks like there's a compatibility issue with some of the latest versions between the versions of the packages that I had. All right, and then sometimes you also in earlier versions didn't like those two, so you can also remove those. But if you want to get a little bit more on Pandas profiling, I'll just show this to you. You can go to the process. So this is the Machine Learning for Engineers course, and there is a there's additional content on Pandas profiling, and that is under statistics and math. Okay, and it'll show you a little bit about what Pandas profiling is and how it generates these reports. So it looks like I had an error here, but I think it's just a version issue. All right, so I'm going to go on from there. The mean density of rock planets is this. Okay, let's calculate the density of the rocky and the gaseous planets. All right, so there it is for the density of Mercury to Mars, but beyond Mars, I'm going to have the gas giants, and so that's going to start with Jupiter. And I always have a hard time when I'm working with the Jupiter notebook not to put a Y there. Okay, and I'm going to go all the way to the end. Let's say you don't know if Pluto is at the end or not. You can just go all the way to the end, and there is the density, okay, of the gas giants. Okay, so now let's talk about visualization or plots. Okay, this is a very important one with just being able to view the data. It can help you identify outliers, any types of trends, things like that, correlations. And it's very easy to do with Pandas. You can create it with dot plot. Okay, but this doesn't tell you a lot. It might tell you what is the, this is the period of the planet, but a lot of these you can't really see them or get a lot of information out of them. Here's the density that's calculated. Okay, but the other ones, it's just hard to see any kind of interesting information from that. So let's go ahead and customize the plot. So we're going to do the plot, but we're going to create it, make it a little bit bigger, 12 by 6. We'll create some subplots and make a grid there. Make a layout of 5 rows, 2 columns, and I'm going to put the pass there. That just so it doesn't show that it's a plot. Okay. Okay, so there I've put them all on separate subplots. Okay, 5 rows, 2 columns. I put in some grid lines so it makes it a little easier to compare values. Now we can also generate other types of plots as well. In addition to just a standard line plot, we have bar, histogram, box plots, and others. So let's go and import matplotlib.pyplot as PLT. I'm going to create a little bit of a nicer graph here just to show some of these different types of plots. And let's just go ahead and create these different kinds of plots. So I'm going to do figure size a little bit bigger, and I'm going to go through all of the different types of plots, and we'll create a subplot axis. All right, there's gravity. All right, so I'm going to show gravity all these different ways. So it's going to go through these different plots. It's going to show the gravity. It's going to show us a pie plot. It's going to show it, let's see, bar, horizontal bar, histogram, box plot. Okay, this is our KDE plot, area, and then pie chart. All right, so let's go ahead and create a bar chart. So I'm going to do PLT, and that's going to be plot kind equals bar of the planet mass. So I don't want to do it of all of them. I just want to do it of the mass of the planet. It has a log scale y-axis. So let's go and put that in as another argument. Log y equals true. All right, so this helps us get, be able to compare because now it's on a log y-axis, and this is the mass. These would be much larger than these, so it'd be hard to compare the two. So here we can see the mass of the different planets. Pluto would be over here, very, very small. Okay, so DataFrame Export. These are the different ways to export data. Now we showed how to do it to dictionary, and we can also do it to Excel, to Feather, to Google BigQuery, to an HDF file. This is a standard file format for hierarchical data that's used in machine learning and data science. Okay, it's a nice compressed way of storing data. JSON, Parquet, Pickle, to records, a NumPy array, to SQL, to Stata. So let's go and just export to a dictionary and then print the dictionary with the mass. Okay, so there's the to dictionary again. We can also go to different types of human readable text. Okay, clipboard, CSV, HTML, LaTeX, Markdown, and to string. So let's just look at string. Just with everything that's exported, you can see the new line characters. You can also do it to a CSV file or to the clipboard and then copy it, paste it somewhere else. So as our final knowledge check here, let's export PL to an Excel file named planets.xls. So I'm going to do pl.toExcel, and that one is going to be named planets.xlsx. All right, and okay, let's see what the problem is here. Okay, it looks like I may have messed up my package versions by upgrading one, but not the other. Or let's just see if I need to import, if I rename something like NP. So import NumPy as NP. Okay, so Pandas requires Okay, looks like I have a different version. So let's go ahead and upgrade that. I upgraded my pandas, but it had some other dependencies. Let's see if I can fix that. Pip install and then XLS writer upgrade. Okay, kernel restart run all. I'll just run these again just so I have PL defined. It has to get it from that data file again, then run through and do all the other modifications that we had there. Okay, let's see where there is an error. All right, it had an error here under the Pandas profiling. I'll go ahead and just get rid of that for right now and then run the rest of the cells, or I'll just do kernel restart and run all again, and that'll just run through all of them. Probably should have done this one at the top as well, because I'll have to restart it again after it gets down to this point. And then, but you know, I'm just, okay, I can't find it. Okay, so no maxing, so one of the problems with upgrading Python packages, sometimes there's some incompatible versions here. Let's go over to here, and I will just go to Google Colab, and let's go ahead and run all of these. And then just to show that it can be done in one of these packages. Okay, so I'm going to see if this will run in Google Colab and see if I can salvage this very last knowledge check. There was an error there just because I had an incompatible version. All right, so installed pandas. Looks like that's already satisfied, already included. Okay, here is the pandas profiling. All right, and this is going to go down pretty quickly through here, and it looks like I had an error here. Oh, it had the same error with Pandas profiling. It's not liking us on that right now. Run it all one more time. Let's see if I can get down to export it into Excel. I'll show you how it puts it in here into the folder. We're going to see it show up here in the files of Google Colab. Okay, and if you had it on your own computer, you would export it to, okay, to your same directory where this is. So this one is going to be planets.xlsx. All right, and it should show up right here. All right, and then if I download that, I can open it up. And then let's see this Excel file that it generated as an export from, okay, so there it is. I have my table. You can see the not a number values are missing if I didn't filter those out. Okay, so that's it for this exercise. I'm just going to come back here to our course, and this concludes the 7 modules that we've covered. We just did the pandas, and if you come back here to overview, you can get an overview of the 7 that we just covered, and we're going to move on now to talking about data access. Now that we have this foundation in the basics of Python, now we're going to be talking about how to access data from text, audio, video, databases, sensors, cloud, and then web scraping. And then we'll go on to transfer and talk about Modbus, MQTT, OPC-UA, WebSocket. Go on and do some time series as well. We have some data engineering as well here. We also have some applications, and I'll be adding to those as well.